So as we continue on our study of static and kinetic friction, we see that they arise from complex interactions at the molecular level. We believe that those interactions are electrostatic in nature. So the idea behind this is that no matter what surfaces we look at, if we continue to look closer and closer down at the atomic or microscopic level, we're going to start to see that every object, no matter how smooth, certainly has maybe some jagged edges, if you will. And those jagged edges have electrons, maybe that are all a part of one surface, and other electrons that are a part of another surface. And maybe what we think is that maybe there's some electrostatic interactions, maybe some momentary bonds that form, or maybe just something that's electrostatic in nature that sort of prevents motion or sort of impedes motion. So it is difficult to know exactly what's happening. What we do know for sure, though, is that maximum static friction is always greater than kinetic friction for any pair of surfaces. So we're talking about maximum static friction. So static friction can grow only so large. If we're looking at the maximum value, we know that that value would be called Fs max. And what that's saying is that that is always greater than F sub k for any pair of surfaces. Now, there's some implications for that. It is easier to keep something moving than it is to start something moving. And you've probably have experienced this at some point. If you're trying to push a very heavy, massive object that's got a lot of frictional force acting between it and the ground, that if you can get it going, it's easier to keep it going. You don't want to have it stop, then it's quite a bit more force to be able to start it moving again. Now, there's another implication. This becomes really important when we're out driving out on the slick roads. There is more available, there's more force available from static friction than there is from kinetic. And this graph sort of shows that. The idea behind available force is if I try to stop my car, and I try to stop my car in a very slow rate, I'm going to be applying brakes at a very small pressure to my brakes, and the static frictional force is going to easily be able to provide that. Okay, so this is sort of showing applied force is how hard I'm trying to stop my car. The frictional force will be able to grow to some value to be able to produce the force that I'm asking for. Now, if I apply the brakes a little bit harder, I'm going to be asking for more force from the static friction to stop my car, and certainly it's able to do that. So we've got sort of a one-to-one correspondence here. So whatever I ask for, the static friction can provide. If I continue to apply the brakes even harder, I'm asking to slow down at a greater rate. Static friction can grow, but it can only grow so high. Once I get to this maximum value, right, so this part right here would be called Fs max. When I get to that value, all of a sudden now I'm going to start to slide. Okay, so if I exceed that value, I'm going to slide, and I'm going to come down here to kinetic friction. So this is where sliding sort of begins. Now, if you think about what's happening for your car with anti-lock brakes, what anti-lock brakes do, a very, very important invention in terms of vehicle safety, is that they prevent the tires from sliding or from locking up. Now, when I start to slide, what I'll see is I'll actually have less force from kinetic than I have at my maximum value. Okay, so this Fs max, again, is greater than the kinetic friction. So the nice thing about anti-lock brakes is it allows us to operate at that peak value. Now, really what's happening is the wheel sort of starts to lock up, and then the anti-lock brake mechanism will initiate sort of a pulsing action where it's trying to keep it operating at the high maximum coefficient of static friction, or the high value of static friction, but then as it starts to slip, it just keeps going back and forth, maybe hundreds of times per second, much faster than you or I could do simply by pumping the brakes.